Okay, so let's just make sure you understand this. So what the first thing is, you have all these hydrophilic amino acids. So hydrophilic means they love. Philic means love. Water. So these are polar. Remember, water is polar. It has a charge, a positive and negative charge. So these guys all have a positive and negative charge also. So remember, water's out here. Positive, negative charge. These guys all have some kind of charge. The charge is N, and I believe these are positive. So what they're doing is they're attracted to the oxygen. So when we plus run here, they all spread out because they all like water. So it spreads out in water. Alright, so hydrophilic spreads out in water because it likes water. They all want to see water. So now we're going to change it to oil. Now oil, remember, has no charges. Alright, so these glutamic acids still have charges, but oil has no charges, and so it's non-polar. And remember, polar and non-polar things do not like each other. They hate each other. Alright, so these guys repel. So what that happens is the hydrophilic molecules are going to all clump together to try to get away from that oil. Alright, so that's what they're doing. They're all trying to get in a group and get away from that oil, protect themselves. Alright, so what we're going to do is we are going to go back and we're going to change it to all hydrophobic. Alright, so now this time we have it in water, but this is the opposite. Now in hydrophobic, when we have it in water, these are polar. These now are non-polar. There's no charge on these. So what's going to happen is, hopefully you realize this by now, they're going to clump up to get away from water. Alright. So now the other possibility is we put them in oil. Alright, so remember, oil is hydrophobic. It doesn't have any charges. So what we do is when we press this, what do you think they're going to do? Hydrophobic likes hydrophobic, so they're going to spread out. Alright, so that's the main kind of gist you need to get out of this. Alright, just for the difference between hydrophobic and hydrophilic amino acids. Because these obviously are going to determine the shape. Obviously our blood is more like water. Alright, our plasma is made up of mainly water, so hydrophilic amino acids are going to bond up together and clump, whereas hydrophilic are going to repel and spread out. And that's going to be key for how proteins shape, because if proteins are made out of a bunch of these, they're going to be all clustered together, where if proteins are made of more hydrophilic things, they're going to spread out. So now we're going to talk about sickle cell. So in the activity, we need to go back here and change these to all hydrophilic. And then it asks us to have val, his, we need the original one. Oh, that is the original one. So we want val, his, lu. So this we need to change to val, his, lu, thr. Alright, pro, and then the glutamic acid. And then on the other side is lu, alla, lu. So, lu, alla, lu. Alright, so this right here is a hydrophobic pocket. You see how they're all hydrophobic, so it forms kind of a little pocket, whereas, and then this is the normal hemoglobin. So when we run this, what happens is, even though there's this hydrophobic pocket here, these don't really bind. This glutamic acid is still pushing those away. Alright, so they don't really bind together. So normal hemoglobin, so this is like a little segment of normal hemoglobin, just trying to show you, is that they do not bind together. So the hemoglobins separate in the blood. Now, if we change this glutamic acid to valine, so our one amino acid change is we changed glutamic acid to valine. Now we changed a hydrophilic to a hydrophobic protein amino acid, and now we press play, and they actually bind together. You see how the pocket, I mean, they're still pushing each other away a little bit, but they still get closer, and that will actually bind together. And this causes the hemoglobins to clump up. Alright, so the hemoglobins clump up in sickle cell, opposed to normally the hemoglobins don't clump up, and we'll show you more of that in the next slide. So this is just kind of a review of what you just had to do.